Hello students, this is Snitha Shetty, Assistant Professor, Department of CSE, HIT Mangalore. So in today's session, I'll be talking about machine dependent loader feature and machine independent loader feature. In my previous session, I explained what is loader and also I explained different functions of loader and different types of loader. So in today's session, we'll talk more about the loader. So that means we are studying two important features of the loader. They are machine dependent and machine independent loader features. Okay. So first one, machine dependent loader feature. So basically, there are two machine dependent loader features. They are relocation loader feature and program linking loader feature. Okay, so these are the two different machine dependent loader feature. So now first one, relocation. So before that, you should know different types of loader. So the loader has been classified into absolute loader, bootstrap loader and relocatable loader, right? So what is absolute loader? In absolute loader, the loader will load the instruction which is specified in the program. For the same address, the loader will load the instruction. Okay, that means the address will be specified in the program, so that we call it as an absolute address. Okay, so for the same address, the loader will load the data in the primary memory. Okay, so so the name is absolute loader. What is bootstrap loader? So bootstrap loader, when you switch on the system or when you restart the system, the initial program must be loaded into the memory. Okay, that is nothing but operating system. Okay, so and that task is taken care by a loader known as bootstrap loader. And what is third category? So third category is a relocatable loader. So what is relocatable loader? So relocatable loader means, assume you have the instruction copy. Okay, so assume the instruction is copy start 1000. I'll be writing here. So copy start 1000. Okay, so this is a instruction. Okay, so that means assume this is name of the program. The name of the program is copy and starting address is 1000. Okay, so the loader must load the program copy in the starting address 1000. But assume during that time, during loading, okay, assume that 1000, the address memory location 1000 is occupied by some other program. Okay, so that what the loader will do is the loader will load this program in some other memory address, I mean some other memory location where it is free. Okay, so that means it has been changed the address. For assume now it is copy start 1000, right? So what will be the next instruction? Okay, so the program begins with the 1000. Assume each instruction is 3 byte. So next instruction will be 1003, right? So next instruction it starts at 1000. So next instruction will be 1003. Similarly, next assume all instructions are 3 byte. So next instruction will be 1006. Okay, so this 1000, 1003, 1006, only if the program is loaded in the memory location 1000. What if now assume there is no space, that 1000 address is not available? So what the loader will do is loader will load the program in some other memory address. Assume it is loading at address 4000. Okay, so that what happens, so the address of all the instruction will change, right? It begins at 4000. So next instruction will be 4003. Next it will be, it is 4006, right? So this feature is known as relocatable feature, or we call this as a relocation. Okay, so this feature is known as relocation. So when that 1000 is not available, the loader will load into some other memory address by changing the starting address. When starting address changes, the address of another instruction also change, and this feature is known as relocatable feature, and this is machine dependent loader feature. Right, so this is machine dependent loader feature. So now we'll see how exactly the loader is doing a relocation. Okay, so the motivation for relocation is efficient sharing of the machine with the larger memory, and when several independent programs are to be run together. Okay, so when you run more than one program, when you run several independent programs, you might get a the problem called as address not available. So that time the loader will go for relocatable loader or relocation. Okay, so this is done in two ways. Okay, relocatable or relocation is done in two ways, that is modification record and relocation bit. Okay, so for relocation there are two methods. First method is modification record and second method is relocation bit. Okay, that means how the loader will tell or how the loader will change the object program. Okay, see, in the object program already predefined address, predefined object code is present, right? But if that address is not available, then that object program must be modified, right? So how it is modified? That modification is done in two ways. Okay, so it is done for the SIC program as well as SIC bar XA program. When the program is SIC bar XE, okay, hope everyone knows what is SIC, what is SIC bar XE. So SIC means just simplified instruction computer architecture. SIC bar XE means it is a expensive or it is a modified version of SIC. When the program is SIC bar XE, okay, when the program is SIC bar XE, then that modification is done through a record known as modification record. Okay, then it is done through a modification record. Okay, when the program is SIC bar XE, that modification is done through modification record. Okay, so when the program is just SIC, when the program is just SIC, then it is done through just relocation bit. Okay, when the program is just SIC, then that modification is identified by the relocation bit. We are studying in detail later. Okay, if the program is SIC bar XC, then the modification is done through a modification record. Okay, so we'll see more about the modification record. Okay, so now we know what is object program, right? So the object program, there are three parts, right? They are header record, text record and end record. We have studied in the previous session also. So modification object program has three parts: head record, text record and end record. So what does that head record contain? Header record contain the name of the program, starting address of the program and length of the program, right? What does the text record contain? Text record contains, it starts with the T, then starting address of the field, okay, then how many object program is written in the text record, that length is mentioned, then all the object program is mentioned, right? So last end record will tell that is the end of the program and program length is mentioned, the starting address is mentioned in the end record. Okay, this is the syntax of the object, any object program. Okay, so now assume there is a modification. Okay, that means there is a relocation. Okay, now what the loader will do is, so since in SIC bar XC there are four different format, they are format 1, format 2, format 3 and format 4. Okay, so in that format 4, okay, format 4 is, it is a just a memory field. Okay, so we know what is the syntax of format 4. Okay, so there the last 20 bits, it is related to the memory. Okay, whereas others are just related to the register, but only in the format 4 it is related to the memory field. Okay, so when in a program, when there is a format 4 instruction, for that instruction the modification, the relocation is mentioned through a modification record. I'll repeat this once again. In a program, okay, in a program, so when you have format 4 instruction, so that time that modification should be mentioned through modification record in your object program. For other program, automatically it will understand. Okay, automatically it is updated all the address. But when the instruction is format 4, then it is identified by the instruction record. Okay, so modification record. Okay, now how to identify the format 4 instruction? Okay, format 4 instruction is identified by the plus symbol. Okay, so assume the instruction begins with the plus followed by some instruction. Okay, so assume the instruction is return address, okay, followed by the loop something. So assume this is an instruction. Okay, I'm giving a sample example. Assume this is an instruction. Okay, so now how will identify this instruction? Okay, since this instruction begins with the plus symbol, so it is nothing but, okay, format 4. Okay, so now when the instruction is format to 4, as I told, so the relocation is identified by the modification record. Okay, now see, you can see your object program here. So the object program begins with at the symbol, name of the program is copy, and some starting address of the program, and this is the length of the program. So next you can see here T text record. So this is starting address of that record. So followed by the 1D, that is nothing but length of all the object program. Okay, then followed by the object program. Similarly, you can see 1, 2, 3, 4, 5 text record. Okay, and usually after header record, text record, and after text record, it will end with end record, right? But here you can see something more, that is nothing but M. So now what is modification record? Okay, what is the syntax of modification record? So in modification record, there are 17 fields. Okay, so the modification record contains 17 fields. So first one, column 1 is M. Okay, so what is the meaning of M? M indicates that it is a modification record. So now column 2 to 7, it is a relocation address. Okay, it is a relocation address. Then column 8 to 9, it is length. Okay, this length. And column 10, okay, it is flag, plus or minus. And column 11 to 17, it is a segment name. Okay, so this is a modification record syntax. Okay, this is modification record syntax. So now you can see here, so you can find M. So what is M? M is nothing but M indicates it is a modification record. So from column 2 to 7, it is a relocation address. So where the relocation address, assume for a address 000, you want 007. Okay, assume there is instruction in 007, and that instruction in 007 is format to 4. Okay, so assume you have the address 0007. Okay, in that 007, that address contain an instruction which belongs to format to 4. Okay, so that time format to 4 means how many byte? 4 byte address. Length of that format to 4 is 4 byte. Okay, so now it needs modification. Now how to mention? See, M. So as I told, 0007. Okay, so from 7, 8, 9, 10, because each instruction is 4 byte format 4, right? It needs modification, right? So in the last displacement field on address field, it contains 20 bits, right? So 20 bits, I'll divide into 4. Okay, so 5 4 is 20. So how many byte? It is 5 byte, right? So length of the field will be, it should be in the half byte, so it is 5. Okay, so the modification is needed for 0007. Okay, so once I'll explain this. So here you can find plus J sub return address, right? So plus, since it is plus, it is format to 4, right? So format to 4 means it is 4 byte. So 4 byte means it is 7, next 8, next 9, next 008. So it belongs to the modification record. So now what is the syntax of format to 4? The syntax of format 4 is opcode, which is 6-bit, next followed by 6 flags, NIXBPE, followed by the 20-bit address. So here you can see 20-bit address, right? So you can count. So 4 plus 4, 8, 12, 16, 20. Okay, now I'll just categorize this 4-bit. So 1 byte means 8-bit, right? So 4-bit means half byte. Okay, now how many half bytes are there? 1, 2, 3, 4 and 5. So we should write this column 8 and 9 in half byte. So how many? So see, this is last 20-bit address field of format to 4. I'm repeating this once again, so don't get confused here. So this is the last 20-bit of format to 4 address field. So how many half byte? 1, 2, 3, 4, 5. So it is 5 byte, and so it is 05, 5 byte. Okay. So this is nothing, sorry, this is 5 byte. Okay, so this is modification record. M followed by the starting address, it is 007, then 5 byte 1 2 3 4 5 byte and name of the program. Okay, so why we externally mention in here in format 4, because format 4 is depending on the memory location. Other formats are, it is register, it depends upon the register, but here this is memory allocation, it depends. So external we should mention in the modification record. Okay, so we are adding extra m into the object program itself. Okay, in the following syntax. So column 1 is m, column 2 to 7 is the starting address. Okay, I mean which address has the format to 4. Okay, next how many byte? So half byte, 1 2 3 4 5 half byte, followed by the name of the program. Okay, so plus means we are modifying it. Okay, so anymore what happens is starting address plus this address. Okay, so for example, if the program begins with the 000, so address is 007, assume that 00 address is not available. So what the loader will do is, loader will load the program in 1000. So that time 1000 plus 007, what happens? 10007. Assume the program, the loader will load the program at 4000. So what happens is 4007. If the program, if the loader loads the program at 8000, so this becomes 8007. Okay, so this is how the relocation is done through modification record, and this modification record is required only for the SIC bar XC program. Okay, modification record is required only for SIC bar XC program. Okay, now let's look at the algorithm. So this, it is a simple algorithm how the relocation is done. Okay, so all the algorithm begins with begin. Next, get program address from operating system. Okay, it will get the address while end of input, while it is not the end of input. So it read the next record. So it will, after reading header, it will read the text record until the record is not end. Okay, until the record is not end. That means until it is not end record. So keep on reading the next input record. Okay, when the next record is T, when is the text record? What does the text record contains? So text record contains all the object codes, right? So move all the object code to the record location address plus specified address. Okay, so move all the code from the record to the location address plus specified address. Okay, so then when the record type is M, add program address at the location plus program address at the specified address. Okay, so this is where you assume the program address is 1000, specified as 00. So where the data will be stored in the 1007. So this is the end of this, and end of this begin, and finally the end of the begin. Okay, so this is an algorithm for relocation, SIC bar XC relocation loading. So now we studied for SIC bar XC program how to identify a relocation. Okay, so how to identify relocation using a modification record. So that record should be added in the object program. Okay, by specifying M. So M means modification record, and we see in the algorithm. So now if the program is just SIC, okay, the program is SIC program. So what is SIC program? Here there is only one format, all the instructions are 3 byte. Okay, so how to identify the relocation? So here the relocation is identified by adding some extra data to the text record. For the existing text record, we will be adding some extra data. Now what is that extra data? So extra data is nothing but relocation bit. Okay, so there in SIC bar XC program, we added a new record itself, right, by starting M. But here we are not adding any new record. Instead, for the existing T record, existing text record, we are adding some extra information. Okay, now what is the extra information we are adding? See, the text record, the column 1 is T. Column 2 is, from column 2 to 7 is starting address of that field, right? From column 8 to 9 is length of the object code. So you can see here one example written here. So text record, so next field is a starting address. Okay, next the length of the object code. So how many object code are written here? 1 2 3 4 5 6 7 8 9 10. So it is 30 byte object code, each is 3 byte. Okay, so 30 byte. So the 30 hexadecimal value is 1e. 30 hexadecimal value is 1e. Okay, so usually we are writing the text record in this way, but now assume there is a relocation. So how to identify relocation? So here the relocation is identified by adding a relocation bit. Okay, so after the length bit, here we are adding a relocation bit. So the relocation bit is added by giving 3 bits. So here we can give any 3 bits. Okay, so by giving 3 bits we can tell that there is a modification. Okay, so this space is mentioned only, this space is available only for the relocation bit when there is a relocation. Okay, now assume, now the object code, so this is the object code which is there in the object program. Okay, so the first object code is 141033. So just recall the SIC object code. So this is nothing but opcode, so that is the address of the destination. Okay, so now assume this is 14. Okay, address of the destination is 1033. Okay, 1033. So this is a next object code, next instruction object code. So next address field is 2103. Okay, 2103. So next is object code is 00, address field is 1039. Okay, now all this, assume there is a relocation. So that means assume 1033, there is no space at the 1000. So the program might be loaded from starting address 4000. So now 1033 becomes what? 4033, right? 4033. Now how to identify? Assume all the object codes are getting modified. Okay, so first object code, this is getting modified. Okay, this is getting modified. Next, so this object code also getting this object code also getting modified. Okay, so I'll just mention one. Okay, next again this object code is also modifying, so I'll just put one. Assume this object code is also modifying. Okay, one. So next this object code is also modifying, one. Okay, now again I'll come to this place. Okay, so assume I'll put one. Okay, that means this object code is also modifying, I'll put one. Okay, assume this object code is also modifying, so I'll put one. Okay, again, so this is also modifying, one. Again, so this object code is also modifying, and finally last object code is also modifying. Okay, assume all these are modifying. Okay, so I have given 3 space, right? So relocation bit means from 10 to 12 I can put a relocation bit. Okay, so see here, so this, so 4 bits first location, next to 4 bit second location. Okay, next 4 bit, here there is no space, so next 3 bit is again third location. Okay, so 1 2 3 4, 1 1 1 1 means what? So 2 power 0, 2 power 1, 2 power 2, 2 power 3. When you add that you will get f, right? So I'll just put here f. Okay, so next 1 1 1 1, so again it is f. Okay, so 1 1 2 3 4 1, next 1 1 0 0. So 1 1 0 0 means it is 12, right? So 12 means a is 10, a is 10, b is 11, c is 12, right? So I'll put c. Okay, so the relocation bit will be ffc. Hope it is clear. Okay, so all the object codes are modifying, this is ffc. Okay, so assume this 2 is not modifying. Okay, so this 2 is not modifying. Okay, so that time what happens, tell me? So 1 1 1 f, 1 1 1 f. Okay, and this is not getting modified, so 0. Okay, so this will be just ff. Okay, so 0, no modification. Okay, so this from column number 10 11 12 is known as relocation bit. So this is in SIC program, whereas in SIC bar XC program we are writing a new record itself, that is modification record. Okay, so next we'll see an algorithm for SIC relocation loader. Okay, so the algorithm says begin get program address from operating system. So begin get program address from operating system, while not end of the input. Begin read the next record. Okay, when the record is not end record, so keep on reading the text record. So get the length of the second data. Okay, and that 3 bit, okay, this relocation bit, so this 3 bit is also known as mask bit. Okay, so this is known as mask bit. Okay, 12 bit why given here, because when there is all bit, okay, it is high, it becomes 12 bit. Okay, actually it is a 3 location, 3 fields, 3 column. So that 3 column is also known as mask bits. Okay, so in algorithm we are saying, so get the length of the second data. Okay, and mask bit is a third data. So if the mask bit I equal to 0, I less than length, when mask bit, until mask bit is 1, keep on adding the program address plus specified address. Okay, if the mask bit is 1, that what is the meaning? The relocation is required. So relocation required means, for example, if it is 1033, the program is loaded into the 4000, it becomes 4033. If the program is loaded in 8000, it becomes 8033. If the program is loaded in the 6000, it becomes 6033, right? So we are doing here, add the program address plus specified address and move the object code from the record to the location address. Okay, and end the record. So this is the end of all the begin. Okay, so this is how we are doing in SIC program. So hope it is clear how we are doing relocation in two different category, in SIC program and in SIC bar XC program. So this is one dependent feature of the loader. Okay, so we studied just first one, that is about the relocation. So what is the second feature? The second feature is program linking. Okay, now what is program linking? The name itself tells it links more than one program. Okay, it links more than one program. Assume you have 3 program. Okay, program A, program B, program C. Now to get the output, you need to link all 3. Okay, because the data of program A might be there in the program B, the data of program B might be there in the program C. So in order to generate the output, you need to combine all these 3 program. Okay, now how you can combine all these 3 program? That is done by the program linking. Okay, so it links more than one program. Hope it is clear. So program linking is we are linking more than one program. Program A, program B, program C. So one program B might be dependent upon the data of program A, or program A might be dependent on the program C. So in order to get the output, in order to execute the program, you need to combine all 3. Then only you will get the output. Okay, how this is achieved? By program linking. So it resolves a problem of external reference and external definition from different control section. So let's see with an example. Assume I have a 3 program. So this you can see here, this is the name of the program. So this is program A. So next you can see program B, and next you can see program C. Okay, so these are the 3 different modules of a single program. Okay, so these are the 3 different program. Now you should combine all these 3 program, then only you will get the output. I'll repeat this once again. Assume there are 3 program, program A, program B and program C. So these are the 3 different programs. So in order to get the output, you need to combine this program. Program A must be combined, program B should be combined with the program C. All 3 programs must be combined. So now how you can do that? Okay, so for that, here I've given a symbol table. Okay, so the 3 control section, program A, program B, program C. So in order to get the output, you need to combine program A, program B and program C. So how you can do this? Okay, so first assume at the same time there is a relocation. Okay, at the same time during program linking, so there is a relocation. Okay, so now what happens is, so starting address is 000, right? So assume that the in 000 some other program has been loaded, so the loader will change the address. So assume the loader will load into the 4000 instead of 000. Okay, the loader will load the instruction in 4000 instead of 000. Okay, so now we'll see what is the program length of each program. Okay, so what is the program length of each program? See, so this is 000. Now as I told, in 00 some other program has been occupied, so the loader will load the program in 4000 instead of 000. Okay, so before that, just calculate the program length of this program A. Okay, calculate the program length. So how to calculate the program length? See, 0000 starting, right? So 0060. Now this 0060, so it is a word, so it takes 3 byte. So 0060 plus 3 will be 0063. That is the end of this program, right? So from 000 to 0063 is the end of the program. So now if the program is loaded into 4000, it will be 4000 to 4063, right? 4060. So what is the length of the program? So length of the program is 4063. 4063, I'll write this, 4063 minus 4063 minus 4000. So the difference, hexadecimal subtraction, so difference is 63, right? So you can see here in this table, so length I have put it as 63. Okay, why? Because so you can see here the program A address is 4000. Actually I had mentioned 000, right? But there is a relocation. The program is loaded at the 4000 address. So the program A, it is 4000. Okay. And the program ends with the 4063. This is the end. 4063. Okay. Now what is the main aim? We need to link all three programs, right? We need to combine. So after program A, program B. Okay. So the program B begins with 4063 after end part. Okay, 4063. So I'll move to the second program, program B. So in program B, you can see here, so this is program B. So the program B is 000. First we'll calculate the length. So program B is 000. So 007C. Okay, 007C, this is word. So this is plus 3. So 007C plus 3. Okay, so it will be around 007C plus 3 will be 007F. So 007F minus 0 will be 7F, right? So the length of the program B is what? Length of the program B is 7F. Hope it is clear. I'll repeat this once again. See, the program B begins with 000 and this is 007C plus 3. So this is 7F. So 7F minus 0 is 7F. So you can see here length of the program B is 7F. Okay, 7F. So at which instruction it will end? 4063 plus 7F, you will get 40E2. You can do the hexadecimal addition. 4063 plus 7F, you will get 40E2. Okay, so at the same address the program C begins because we are combining it, right? So program A, program B, program C ends with the end of program B. It is 40E2. Okay, now we'll go to program C. So program C, the starting address is 0. So here 0 last address 004E. So plus 3, when you add 4E plus 3 hexadecimal addition, I think you'll get 51. So 51 minus 0 you will get as 51. So length is 51. So this is the length of program C. Hope it is clear. So the length of program A is 63. Length of the program B is 7F and length of the program C is 51. Okay, and the program A begins with 4000, program B begins with 4063 and program C begins with the 4082. Okay, so now look at the program A. So the program A wants the data from program B. Similarly, program B wants the data from program C. So this we call it as an external reference and the data is defined here some other program. So we call it as an external definition also. Okay, now we'll solve that. Okay, so now see list A. So list A, okay, so here it is 0020. So here it is list B, list B. So list B address is 0060 and list C address is 0030. Okay, but the starting address has been changed, right? So what we are doing is, see list A, it was what? 0040. So how you will get the address? You add that 4000 plus 0040 is 4040, right? So list B address is how much here? 0060. Okay, so program B begins with 4063. So 0060 you will get list B as 40C3. Okay, in list C, you can see it is 0030. So 0030, how you will get that? 0030 is obtained how? By adding 40E2 plus 0030. You will get how much? 4112. Okay, so this is how it is obtained. Okay, so this is how the list address is obtained. Similarly, you can obtain the address of end A. So how end A address is obtained? So look at here in the program A. So the end A, right? So end A, it is 0054. So how 0054 plus 4000, you will get 4054. Okay, similarly end B. So where is end B in program B? So end B is obtained in 0070. So you can add 0070 to 4063, you will get 40D3. Okay, similarly end C is how it is obtained. So 40042, 0042 plus 40E2, you will get 4124. So this is how it will solve external reference and external definition. So it resolves the problem of external reference and external definition. So I explained how it solves external reference and external definition using a symbol table. Okay, so to do this, it will use two passes. Okay, it will use two passes. So what is pass 1? In pass 1, it will assign address to all the external symbol. In pass 1, it will assign address to all external symbol. Okay, so that means it will assign the first, it will assign all address. Okay, that means so you can see here the address of program A. So 0020230027545. So here in the program B is 00360. So in pass 1, so here 0180001C. So this is nothing but address of all the instruction. So in pass 1, it will assign the address for all the symbol. Okay, and here the variables required are program address, control section address, control section length, and establish. Okay, so next in pass 1, we'll look at the algorithm, how it is doing. Okay, so the pass 1 will get the program address from the operating system. So that means make sure that the address is free available. In case if that address is not available, it will change the address, so that address will be available in the program address. Okay, and set the control section to that program address. While it is not the end of input, read the next input record, keep on reading the each record. Okay, first header record, next text record. Okay, so set the control to the control section length and search the that symbol table. Okay, establish for the control section name. Okay, so if same flag is found, it is a duplicate flag. So otherwise, enter the control section name. Okay, and while it is not end, read the input record, and record type is record type is D. So each symbol in the record, search the establishment of the symbol name. Okay, if again it is found, it is a duplicate record, so enter the symbol in established table. Okay, and end the record. So when it is not end, see whether it is a matching. Finally it will end the record. Okay, so this is how the program 1. So I explained here with the example. So just go through this variable and understand this algorithm. Okay, so in pass 2, so what happens is perform the actual loading. So in pass 1, it just calculate the address, right? In pass 2, it perform loading, relocation, and linking. Okay, and if there is any modification, that means if there is any relocation in SIC program, SSC bar XC program, then modification record is established. And if the end of the record, so it will get the enter address, and it will process the text record and the modification record. So again here there is an algorithm for the pass 2. Okay, so pass 2 algorithm is like this. So get the program address from the operating system. So set the CS address to the program address. So while it is not the end of input, keep on reading the record, set the control section length, and search the symbol table. Okay, if the same flag repeats in the symbol table, it is a duplicate flag, and until it is not end, and if the record type is D, see it read the table. Okay, and if the same flag repeats, it is a duplicate table, and keep on adding that address. Okay, pet control section, and until it reaches end, do this, finally end this. Okay, so this is how the program linking is done. Okay, hope it is clear. So program linking, mainly to execute the program, you want the data from other program, so we go for program linking. Okay, so next we'll go for machine independent loader feature. So what is machine independent loader feature? In machine independent loader feature, there are two categories. That means there are two features. First one is automatic library search feature, and second one is loader option. Okay, so what is automatic library search? Okay, so before that, what is library function? Okay, for example, in C program we have as include stdio.h, right? So we include stdio. So why we need stdio? Because printf and scanf is present in stdio. So without that we cannot execute a C program. Similarly, here the compiler and assembler uses so many library files, okay, and which is automatically called. So many linking loader automatically incorporate the routine from the subprogram library into the program being loaded. Okay, a standard library or other library may be specified by the control statement or by the parameter to the loader. So it is automatically library called in some system. Okay, so automatically the function will be called. So this is known as automatic library search. Okay, so how it is implemented? So first, the linking loader that supports automatic library search will keep track of external symbols that are referred and which is not defined in the primary input to the loader. Okay, and at the end of pass 1, when the symbol table is established, it remains undefined that means it is unresolved external symbol, external reference. Okay, now when it is an unresolved external reference, the loader will search the libraries of all the routines that contains a definition of this symbol. Okay, and note that the subroutine fetched from a library in this way themselves contain the external reference. And also it is therefore necessary to repeat the library search until the reference are resolved. Okay, so it is not calling only once until the reference is resolved. So it will be keep on calling the library function. Okay, so this is the implementations of the automatic library. Okay, so next is the loader option. Okay, so before that, the process allows the program to override the standard subroutine by supplying the user routine. Okay, so here the process will allow the programmer to allow the standard routine. Along with that, it will support the user defined routine also. So supply his or her routine. Okay, and the library to be searched by the loader ordinarily contain assembly or a compiled version of the subroutines. Okay, and for efficient searching, it will use the different directories, and some operating system can keep the directory for commonly used library permanently in the memory. And the same technique applies equally well to the resolution of the external reference to data items. Okay, so this is how the automatic library search is called. So next feature is a loader option. So what is loader option? So here the menu loader allow the user to specify the option that modify the standard processing. Okay, and menu loader have a special command language. So the loader, while loading, it might use its own option, okay, in order to load the data, in order to do its work. So it will use its own command language. Okay, for that it might use separate input file, or it might use an embedded, which is embedded in the input stream or in the source program. Okay, so what are the different loader option? So some command language loader option are include, delete, change, and library, my library, and no call. So these are the 5 different loader option. Okay, so what is first one? Include. Okay, so it will include the program name. Okay, along with the program name, it will include the library name. So I'll repeat this. The first loader option is include. So it will include the program name along with the library name. You can look at the example here. Include, the program name is read and library name is utility library, UTLIB. One more program name is write. It will include the library file for that, utlib. So direct the loader to read the designated object program from a library and it treat it as if with part of the primary loader input. Okay, so along with the program name, it will read the library name and it will take it as a part of the input. Okay, so it is if the loader wants to delete the section, okay, so it delete the record, it will use an option delete control section name. Okay, so the for example it is delete read record and comma, you can add number of control section here, any number of control section here. So delete read record comma write record. Or so if you want to change the name of the record, so the syntax is change name1 comma name2. Okay, it causes the external symbol name1 to be changed to the name2 wherever it appears in the object program. Okay, so it will change name1 comma name2. This, it causes the external symbol the name to be changed from name1 to name2. So you can look at the example here, change read record comma read. Okay, so this is how it works. So first three loaded options are include, delete and change. Include, delete and change. Okay, so what is the fourth loader option? So the fourth loader option is library, my library file. Okay, so here automatically how the library is called. So automatic inclusion of the library routine to satisfy the external reference. So this is searched before the standard library. Okay, so it will call the function my library. So this is the automatic inclusion of the library routine, and this is called before the standard libraries. Okay, and finally last one is no call standard deviation plot and kernel. What is this? For example, assume you have included in the program, you have added a header file hash include math.h. Okay, assume you have added a function hash include math.h. So math.h means it has so many files, right? It has square root, standard deviation, plot, function or colon. It has so many function under math.h. So in that, for time being, you are using only square root. In that you are using only square root, and you don't want standard deviation, you don't want plot function, you don't want current function, you want only standard deviation, you want only square root function. Okay, you have included math.h file, but in that math.h file there are so many other functions like standard deviation, plot and kernel. Okay, so you need only square root, so you don't want standard deviation, plot and kernel. So you will be writing an option no call standard deviation, plot and kernel. So this will instruct the loader that this external reference attribute remain unstored. Okay, that means you are not using the function of standard deviation, plot and kernel. Okay, so these are the 5 options of loader: include, delete, change, a library function and no call option. Okay, so last one is the difference between the linker and the loader. Okay, so the difference between linker and the loader. So there are three things here. So first is what concept we are using for the difference. Okay, we're looking at the basic, input and finally the function. Okay, now the basic of the linker. So what is linker? The linker generates the executable file of a source program. The what the linker is doing is, see, we are seeing the difference between the linker and loader. So what is linker? A linker will generate the executable file of a source program. Okay, so the linker is generating the executable file of a source program. But what the loader is doing, loader is loading this executable file into the main memory. Okay, so before the loader does some task, the linker should do the some task, then only the loader can continue. Are you getting this? So the linker will generate the executable file, the loader will take this executable file and it will load into the main memory for execution. Okay, and second one, what is our input for the linker? So see, the user will write the program in high level language. That language should be converted into the machine level. And who is doing that? The translator is doing that. And who are the translators? The compiler and the assemblers are known as translator, right? So the linker will take the input from input and object code which is generated by the assembler or the compiler. Okay, so the input for the linker is output of the translator. So translator means either compiler or assembler. Okay, so linker takes the input and object code which is generated by the assembler. And what the loader is now, what is output from the linker? Output of the linker is an executable module, executable file. Now loader will take this executable module and which is generated by the linker, okay, and it will give it to the memory. So loader takes this executable module as input which is generated by the linker. And what is the last function? The linker. Why the name is linker? So it combines, the linker combines all the object module of the source code to generate an executable model. Okay, module. The linker combines all the object modules of the source code and it will make it as one executable module. And loader will allocate the address for all this executable module and it will place it in the main memory. Okay, loader will allocate the address to an executable module in main memory for execution. Okay, so this is a difference. So the linker is giving an input for the loader. Okay, so the linker is taking the data from the translator, it is making ready the data, then only loader can do that. Okay, so loader is taking the data from the linker. Okay, at the same time it will load the data into the main memory. Okay, once the data is loaded into the main memory, loader will give the starting address to the computer hardware, so the execution begins. Okay, computer hardware will come to know where the data is being stored and from there the execution takes place. So students, in today's session we have seen machine dependent feature and machine independent feature. So machine dependent features are relocation and program linking, and machine independent features are assembly files. Okay, the library files, and we have seen different loader option. So the different loader options are include, delete, change, my library and no call, and we have seen the difference between the linker and loader. So we'll study more about the loader and linker in the next session. Thank you.